Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 88 in our incredible new tutorial series where you're learning how to think like an engineer using the Arduino Uno R for Wi-Fi. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons, and in this class we will be using the Sunfounder Elite Explorer Kit. Now hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's talk about what I am going to teach you today. And I'm going to show you my solution to the homework assignment that I gave you in lesson number 87. Now, in lesson number 87, I showed you how on the Arduino that you could sit and you could make all those measurements on the magnetometer as you were moving the project to all possible orientations. And then by properly capturing X max, X min, Y max, Y min, Z max, Z min, then the system could come up with the calibration parameters, the offsets and the scales to then get good readings from the magnetometer where you could actually get a fairly accurate reading on heading, or basically a digital compass. Now, what was the challenge with what we were trying to do last week? The challenge of what we were trying to do last week is as follows. Let's see if I can come over here and let you see this. This was how the code ended up. Let me get it moved up here where you can see it well. Okay, this is the code as we ended up. Let me get out of your way. And you can see we've got this long string of numbers. And as we are watching those long string of numbers, we got to pick one column and then we've got to rotate along that axis. Like I'm trying to here, this is north. I'm trying to show the X magnetometer, that magnetic vector. So I'm just tweaking it around in this position, trying to get this first number as large as I can by pointing exactly at the magnetic vector. And then I've got to do that for the max, the min on X, Y, and Z, which is like 6 numbers. Then I calculate 3 offsets, and I calculate the 3 offsets, and then I calculate the 3 scaling factors. And the bottom line is you end up with this huge thing of numbers, and it's really hard to get a good calibration because remember last week how we struggled, like, now which one of these columns am I looking at? And if you pick the wrong number, if you pick the wrong column and get a number off the wrong column, then your calibration things aren't good. So what your assignment was that we wanted you to go in and pass the data over to Python on your PC, and then once you got it over to Python on the PC, then create some visualization tools that would help show you graphically the progress of your calibration, where you could sort of more easily see visually if you're getting to that absolute maximum point in your X, Y's, and Z's and your minimum points in your X, Y's, and Z's. Okay, does that make sense? Hopefully you see this. Hopefully you see this is not a very easy way of doing the calibration. Okay, so what we're going to do is we're going to go back to our simpler program. We're going to go back to our simpler program from a few weeks ago. So you're going to go to the most excellent www.toptechboy.com. We're going to go to the very simple program that we wrote there, and that was just taking the raw readings for X, Y, and Z from the magnetometer. You can use the happy little search icon and you can search on using the QM MC5883L magnetometer on the GY-87 module. And this simple program is going to allow you to just pull the data in, okay? And so we're going to come here, and then we're going to get this code. There it is. And so I'm now going to run that one. And hopefully here we should just get XYZ, and it'll just be the raw numbers, okay? And there it is, just raw X, raw Y, raw Z. We see that they're changing live, and so that's great, just simple XYZ. What do we want to do? We want to pass that to Python on the desktop, and I'm just going to do it over the serial monitor. And so the way you do it, you just print it, okay? But instead of printing it to the serial monitor, you're going to grab it, you're going to intercept it in Python over on your desktop. Now, the one thing that I have to tell you is you can't have the data coming to the serial monitor and Python at the same time. So what I've got to do is I've got to turn the serial monitor off. The serial monitor is off. Now I can grab that data in Python. Okay, so how do we do that? Couple of things that we have to think about. The first is that we're going to do it. Now, probably the best way, and maybe we'll do this eventually, is to do it over Wi-Fi, and that way we don't have to have this cord. We could do the calibration without having this cord slowing us down, and maybe we'll add that enhancement. But the easiest way to get data from Arduino to Python on the desktop is just using the UART or the serial the serial command. We're already putting that data on the serial port. We just got to grab it in Python. Now we are going to be using PyQt to plot the data so we can see if we're getting that circle as we're doing our calibration and not have to look at that table. So we're going to be using PyQt. So the first thing that we're going to have to do is we're going to have to manage some packages. Okay, so we're going to manage some packages. The first thing that you need to install, is, if we are going to be using, I should also say, if you guys are drive-by shooters and are not taking all of these lessons, if you want to install Python in Thonny, install Thonny with Python, just like I have here, you need to go back to lesson number 63 in this playlist, and that'll show you how to install Thonny and get Python up and running, and then you could just jump right in where I'm starting here. But I don't know, your installation of Python might or might not have PySerial, so you need to make sure that you have PySerial. So you search on PySerial, and then there it is. Okay, there is PySerial, and you can see that for me, I already have installed version 3.5. Okay, I have version 3.5 installed, and so I don't need to install anything. It very well could be that PySerial comes with the Python install these days, but that's not all you're going to need. Manage packages. Besides PySerial, you are going to need PyQt. You got to put it in right. PyQt5, like that. Let's look for that. And you can see there it is, PyQt5. Okay, and you can see that I've got version 5.15.11 installed, and so that is great. I've already installed it. If you don't have it installed, reach down and press PyQt5. Now there's one more here that we need, and that is going to be PyQt graph. And if you did those lessons back around 63 on, or where I was working on the PyQt, you've already installed these, but I'm just showing for a guy that just might drop into these lessons. Okay, PyQt graph. And there it is, PyQt graph. I'm on 0.13.7, and so that is that's very good. And so now I've got those. Now when you install those, I think those should probably install NumPy as part of that, but just to make sure, you're going to need NumPy. So search on NumPy, and then there it is. You can see I have it installed. I have installed version 2.2.1. Hey, there's a newer version 2.3.2, but I'm just staying here with 2.2.1, and that's going to be good. That's going to be good for me. There's usually not huge changes in these things, okay? So we should be okay there. So those are the things that you need to make sure that you have installed, and in case PyQt5 or PyQt-Graph had not installed NumPy, then you need to install it. If it's already there, I would not upgrade it. I would just leave the one that PyQt-Graph or PyQt5 wanted. Okay, so now what are we going to do? We're going to try to grab the data off of the serial port, and then we're going to try to graph it, and that way we can get those calibration parameters as we're visually looking at live graphs that we're going to make in Python. Okay, so we're going to need to import serial, and that will allow us to grab the data off of the serial port. We're going to need to import NumPy as NP. Mainly NumPy, we're going to be dealing with arrays, right? Arrays of data, and the NumPy array functions are faster than just and better than the native Python array functions. And so we're going to be using NP to handle our arrays, and then we're going to make some PyQt5 widgets. So import PyQt5. I need to do this better. I'm going to say from PyQt5. We're just going to import the things we need, which are going to be the Qt widgets, and the Qt core. All right. Now we're going to also want to make some graphs in there, so we're going to import PyQt graph as PG. Why do we do it this way with the as? Because every time I don't want to have to type PyQt graph when I want to use a method from that library, or I don't want to type NumPy every time I want to use a method from that library. So I import it as NP or import it as PG. Let's just make sure that we have those libraries installed. Yeah, I ran it. I didn't get any errors. That's good. Okay, now I'm going to create a serial port, and that's going to be equal to COM8. So this is how you set up the serial port in Python on the PC. Now, if you got a Mac, there's going to be two commands you're going to have to figure out how to do for your Mac, and it's easy enough to look at, but it's easy enough to look up, but you got to tell it which COM that you're looking at. Probably there will be a unique command in, for a Mac to do that. And then we're going to set our baud rate. Okay, our baud rate is 115/200. And man, before I forget it, I better come over here back to this and make sure, yeah, you see I'd set it at 115/200. So those have got to be on the same baud rate, of course. And now I'm going to set a timeout, and that's going to be equal to 0.1 seconds. And now here is kind of your money. Here is kind of your money command here. And that is, I'm going to create my serial object, and it is going to be serial.serial, and then serial port that I just set up, the baud rate that I just set up, and the timeout. And so that is going to be timeout equal, I don't like how I did that really. I think I'm going to call this TO. So the timeout is equal to TO. I just hate using the same variable name kind of in two different ways. So I'm going to set that timeout as TO, so the timeout is equal to TO. And you did not see that, and you're going to yell at me pretty soon if that goes behind there. Okay, I think that is pretty good. Let's see, I think I'm going to do just a little quick check here if I can figure out how to do that. And then what I'm going to just do here is, this is just to see if I can read that data in, okay? And so what I'm going to just do is I'm going to say while true, when it's true, true is always true. And then I'm going to say, I'm just going to say, see if I can do it. I'm just going to read the line in, and the line is going to be equal to serial.read line like that, dot decode like that, and then UTF-8 like that. And I'll talk about this in a minute, but I just want to get it typed in. And then I will strip off the nonsense. Okay, strip off all the nonsense, and then say print true or print line like that, and then time dot sleep of, let's say, let's not do a time dot sleep. Okay, it should just read the data as it comes in. And so let's see, I might have just oversimplified this to the point that it's not going to work, but I just want to see, before I do all the fancy stuff, if I can just get the data over. Okay, so I've got line is serial, SER, my object dot read line dot decode UTF-8 dot strip. Okay, let's just see if this thing works. Serial port is not defined. Where is that? Serial port uppercase. Make sure that we type these things in the same. Okay, let's try it again. Okay, could not open ports. Okay, so now that is a very, very interesting thing there. Let's see what's going on over here. Okay, look at that. I had an extra Arduino program running, and it had the serial port open, and that was locking it up. Okay, so I'm glad that happened. So if you get true is not defined. Well, okay, what is it? Is it like while true? TRUE? Yeah, it looks like it likes that better. Okay, boom. Okay, what do you see here? I'm getting the data coming over. Now, this is a very terrible way to do it, and you see there's blank lines where I'm out trying to read and there's nothing there, and then it doesn't like it and it skips lines and stuff. And so when we do it for real in the program, we're going to do it more carefully and more deliberately. But what did I want to see? I just wanted to see that I could get the data from Arduino into Python, and we've got that going. So now I'm just basically going to take this out. That was just to see if we were able to get the data in, because you see, we're going to do a lot of fancy stuff here. And what I don't want to have happen is, I don't want us to get into this and then be trying to debug our pulling the data in, as we're having all types of stuff going on with graphing and other things like that. And so that's good. We've got that. We've got the data coming in, and that's actually probably half the battle. Okay, now what do I want? I don't want to, I'm going to be reading in data and plotting that data, but as the program sits there, I don't want it to take in thousands and thousands and thousands of points, because then the graphing would get very, very slow. So I want to have the max points that I'm going to bring in is going to be 2,000 points. Okay, 2,000 points, right? Very good. Now, what does that mean? I'm going to be reading the data into my NumPy arrays, and when I get 2,000 points in that array, I'm going to start kicking out the oldest point before I bring the newest points in. So those three data arrays are not going to have more than 2,000 points in it to keep things moving along snappy. Now I'm going to have X raw, that's the raw data, is going to go into an np.empty and a 0. So what is just this saying? This is creating an array, a NumPy array, that is going to be called X raw, and it's going to start out empty without anything in it. But what type of an array? It's going to be a one-dimensional array. So 0 means one-dimensional array, okay? And so that's the shape of the array, 0, okay? Now we're also going to do the same thing. So I'm going to copy, and then we're going to paste and paste up. We are going to paste and paste. And then what else am I going to want? I'm going to want an array for the raw Y data and the raw Z data, like that. Okay, does that make sense? Let's see if I got anything else there. Yeah, that's good. Now, I'm ready to start with my PyQt5 stuff. So what do we need? We need to create an app, and the app is going to be equal to the Qt widgets dot Q application, and then we talked about this when we were doing this. So now I've got an object that is the application. Okay, and then really what I want to do is I want to kind of finish the program so I don't forget to finish the program. So all the action is going to happen between here and here, but now I want to finish the program cleanly. So what I'm going to do is I'm going to start that application that I just created. So this command app.exec is going to start that application like that. And then when I quit the program or the program crashes or whatever happens, finally what I want to do is I want to serial.close, okay? Because remember how when Arduino had grabbed onto that that serial port and then I couldn't run this program? When this program dies, I've got to make sure that it releases that serial port. So we're going to serial.close. Okay, so that is like that. Now we're going to come back up here. And then what are we going to do? We're going to start building our widget, okay? And so we created the app. Now I want to create the main window like that, and that's equal to Qt widgets dot Q widget like that, okay? And then I'm going to give a main window dot set window title. And then what are we going to call this window? Magnetometer that's only got one L, I think. Calibration. Close, close, like that. Now, I like to, like when I create something, I like to end it. So right, this is like an onion that we're building, and I start it and I end it, and then I create the window. Now what I want to do is I want to make sure that I don't forget to show the window. And so that's going to be the last thing we do down here, which is main window dot show. Because otherwise we're going to spend 45 minutes trying to debug it and realize the problem is we made the window, but we never showed it. Do you think this would run? I wonder if this would even run now. Boom. I got a window, and it's magnetometer calibration, and I didn't get any errors. Hey, this is pretty cool. You guys got a lot of you guys got very impatient the last time I taught PyQt5, and I will admit some of those lessons got really, really long, and so I'm trying to not make these lessons as tedious. And if you hate PyQt5, you know my code's going to show up on the website next week, and you can just copy it if you just really don't want to go through this. But hopefully it's a little easier this time. Most of you guys, this will be your second time at it. Okay, so now I have a window. Well, I need a main layout. How are those widgets going to go into that window? Qt widgets dot QV. I want the widgets to go in vertically. I want them to stack vertically. Layout. So QV means vertical layout, like that. Okay, now what do I need? The main layout, the main window that I just created. I need to tell it what its layout is going to be, and it's going to be the main layout that I just created. Does that make sense? I hope it does. So this isn't going to do anything because I'm just giving placeholders, right? I'm just giving placeholders for the things we're going to be putting in. But let's run this and look at that. Okay, look at that. I made a typo. And so this is main layout is qt widgets dot qv. It's the box layout. Okay, but you see, it's much easier to find these little errors as we go than it is to just have a big old long program and not really sure what's going on. Okay, so now that, let's see now. I don't know why it started making that real small like that, but we'll assume that that will get sorted out as we go along. Okay, now what I want is inside that main layout, I want a layout inside of that for plots. So I'm going to make a plot layout, and that's going to be qt widgets, and then what I want to do is a q grid layout. Now, what is a grid layout? A grid layout would be where I would want to have, like, inside my window, like 3 by 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and then I could put plots wherever I wanted in that. I want to have a grid that inside my main window I can put more than one plot. So we're going to do it like that. I'm still worried why that thing started showing up real small like that. I'm worried why that was showing up real small like that. So as I'm trying to be confident in teaching, I'm getting a little bit scared why that was doing that, although it was working before, but we'll hopefully get it figured out. So I've got the Q grid layout. Let's see. Okay. All right. Now what I'm going to do is, now I've got that grid layout, but I need to main layout dot add layout what? Plot layout. And I hope you're starting to see this as an onion, like I've got a window. Inside the window, I've got a main layout. Inside the main layout, I have the grid layout, and now I have the plot layout. So you see, it's kind of this onion that is just unpeeling itself in front of you. Okay, so main layout, add layout, plot layout. All right, now I need to create the little boxes for the plots inside the grid. So what am I going to want? I'm going to want an XY plot. And why do I want an XY plot? Well, this table is the XY plane, and I'm going to be rotating this in the XY plane, and so I want to plot the XY data. I want to plot the data from the XY plane. So what am I going to call that? I'm going to call that the XY plot. And that is going to be PG for the, what was it, PyQt graph up here, the PyQt graph library PG. So I'm going to create a plot widget. And that plot widget is going to have a title, and that title is going to be the XY plane. Okay, like that. And then I think I'm going to live dangerously. And what do we have? We have the XY plane here, and then here we are going to have the XZ plane, and then here we're going to have the YZ plane. Okay, so we're going to have 3 different planes that we need to be able to plot the data for. So I've got the XY plot, and all of those are going to be the same, but what is going to be different? I'm going to have the XY plot. I'm going to have the YZ plot is the YZ plane, and then I'm going to have the XZ plot is the XZ plane. I wonder what happens if I run this now. Let's see. There it is. Okay, that is still a little bit confusing. Looks like there's something a little bit unhappy there, but I am not getting an error. And so I hope that's not one of those things where It just doesn't give you an error. But you see, I haven't put anything in yet, and because I haven't put anything in yet, it doesn't have anything to fill up that space, or at least I'm going to keep telling myself that. Okay, we're going to need to set some characteristics for that, so I'm going to just do a quick for loop for plot in, what am I in? I'm in XY plot, comma, YZ plot, comma, XZ plot, like that. I think these are easier if we put a little space in here. So I'm going to step through the array of the names of my different plots, XY plot, YZ plot, XZ plot. And what am I going to do? I'm going to set plot, which is going to be like XY plot dot, YZ plot dot, XZ plot dot, right, as I step through them. Okay, so it's going to be plot dot set aspect locked. So I don't want this thing changing sizes in random ways, so I want to lock the aspect ratio. Now I'm going to plot, I want them to all show a grid, and I want them to show a grid in X and Y. Okay, so as I'm reading the graph, I want that little grid on the graph that it'll make it easier to read. Okay. All right, and then plot dot set minimum size. I want to set it at 300 pixels by 300. Okay, because that'll be something that I can read. Okay, now what do I do with that? Now I've got this plot layout, right? So what I'm going to do, the plot layout that I created, I'm going to add a widget. What widget am I going to add? I'm going to add XY plot that I just created, and then where do I want it? On row 0, column 0. Okay, so that'll be the upper left corner. Now, this I think should all be very similar. Man, you live by cut and paste and you die by cut and paste, but let's try it. So the XY plot is going to be upper left, and then this is going to be row 0, column 1. So this will be the upper right, and this will be the YZ plot, and then this will be the XZ plot, and I filled up the 0th row, so now I need to go to the next row, and this will be the bottom left corner. So there's sort of like 4 places for plots. Right now we're using 3 of those. Okay, so I think we've got that pretty much set up, and yeah, we added the widget. So now these plots are inside the layout, inside the window. Let's see what happens. Let's see, in line 27, we have an error. Did I misspell? Minimum. Okay, do you see why it's nice to keep checking as we're going? It's nice to keep checking as we're going. Boom, man. You don't know how happy I am. You could not understand the panic I had as I kept getting that tiny little munchkin window. Like at first it was the right size, and then it collapsed because I added empty things in there. And because I added empty things, there was nothing that would there was nothing that would keep the window expanded. But these, I made it like at least 300, right? And because of that, then I got something that looks nice. Now I wonder if we resize this window. I wonder how smart it is if we resize it. Look at that, it kind of fills up. And then there'll probably be a small size that, yeah, you see it's not letting me resize it smaller than 300 by 300. So it actually makes sense. Man, I was panicking because I thought, should that really be collapsing on me like that? Okay, so we've got three beautiful graphs there that are coming along. I've done the plot layouts, but you see those are just kind of blank plots. They're just kind of blank, dumb plots. Let me look at that again. Did they had a grid, but I'm wondering, there was no data, so I'm even kind of wondering. Yeah, you can see the grid. And since we didn't have any other thing, it just said, okay, I'll make it 0 to 1, 0 to 1.5. These are just probably generic defaults. But you see, I got the nice grid with the major the major grid lines and the minor grid lines. And that's really good. I got the titles. Those are looking good. Looking good. Looking good. Okay, so now we've created the kind of placeholder for the plots, but what kind of plots do we want there? There's all kinds of different plots. So I'm going to say I want scatter plots. Well, I want an XY plane scatter. So this is what I'm naming it. And that's going to be the PG for the PyQt graph. And then I'm telling it here, I want it to be a scatter plot item. And I'm going to say that I want size equal 5. That's probably the size of the dots that it's going to put on there. We're going to live dangerously here, and we're going to copy this. Okay, so there's XY, there is YZ, and there is XZ. So those are the three planes that I'm going to be dealing with, right? Those are the three planes that I am going to be dealing with. So that is that. Let's just make sure we don't have an error. Because when these programs get a little longer, ooh, I didn't know what a scatter plot item, PG dot scatter plot item. Interesting. And it's line 32. It's the first one. XY scatter. Statter. Oh, that was a bad one, and I copied and pasted it. Okay, let's go. This won't do anything, I think, except we just want to see if it runs. Yeah, because you see, why did it not do anything? Because we haven't sent any data yet. All right, but it knows that when the data comes, it is going to be a scatter plot type. I'm not sure what all the different types are, but scatter is what we need. Now we want to bring this to life, okay? So I'm going to define the function that is going to kind of bring it to life, and that is going to be update plot, okay? That's going to be update plot. Now, if we're going to create update plot, we're going to need to make sure that we're running update plot. So before I do anything else down here, I want to create my timer that is going to be calling that, so I don't create a beautiful function and it doesn't work because I forgot to add it. So again, I'm kind of, if I start something, I want to make sure that I'm doing the bottom part of it, and then I'll fill in the juicy details in the middle. Plot timer is equal to qt core.q timer, like that, okay, and then plot timer dot timeout dot connect. So when I get to that timeout, what do I want to do? I want to update plot like that, and now plot timer dot start. So now I'm going to start, and I want to run this thing every 50 milliseconds. So every 50 milliseconds, I'm going to update that plot. That would be 20 times a second. That is pretty darn fast. Now, if I do this, I got to put at least something in here. Again, I'm just trying to run and make sure that this thing is going to be working. Okay, now what is this doing? Absolutely nothing, but it is sitting there calling update plot, and we're not getting any errors. All right, I kind of feel like I'm in my zone today. Do you feel that? I feel like that we're really cruising through this. Okay, but we don't want to really pass. What we're going to have to do is the things that we want as global variables are going to be what? Our friend X raw, our friend Y raw, and our friend Z raw, like that. Okay, now if serial.in waiting is greater than 0. So what is this saying? If there is serial data waiting to be read, then we're going to read it. But we're not going to try to read it if there's no data there. Now remember, when I first started this program, was just running it, it was like getting blank lines and stuff. Why? It was forcing a read when there wasn't data there. Now this should take care of that problem. Now we want to do a try and accept here. Why do we want to do a try and accept? Because if we read and somehow get malformed data or something bad goes wrong, kick it out and just try again, okay? And if we do a try, I'm going to go ahead, right? I always like to kind of finish things. I'm going to do the accept. And the accept is if we get an exception as E, as an error, what do I want to do? I want to print parse error, like that. And then I want to print that error. Now, why do I do this? If this thing dies in update plot, it'll just crash, and then I need it to show me the error that caused it to fall out of there, okay? So what am I going to try to do now? I'm going to try to read that line. So the line is going to be equal to, don't you wish we'd saved this earlier? Serial dot read line, okay, dot decode dot UTF dash 8, okay, UTF dash 8. And UTF-8, and then what? Dot strip, like that. Okay, and then let's just print line. Okay, now what I hope happens is we don't get those errors, that it's just going to be reading and printing and reading and printing, and we don't get those blank lines, or we don't get those blank lines. So we're going to try to actually read that data in here and print it inside this big mess. Boom. Okay, so the graph is happy. Nothing's happening on the graph because all I'm doing here is I'm reading and printing the data, but you see how it's all coming in nicely formed. I'm not getting those random blank lines in there. Okay, so that makes us very happy, doesn't it? Now, that is a string of comma delimited values. So what I want to do, I want to create an array called values, and that's going to be equal to that line that I just read in dot. Oh, man. Okay, that's it. I'm sorry. That was behind the veil. But we got it taken care of soon enough. Okay, values dot line. Values is equal to line dot split. I want to split that. And I want to split that array on the what? On the delimiter, which was the comma. All right, now I've got values. Now, if the length of values is equal 3, there should be 3 numbers there. What if something got lost in translation or moving over and you got a malformed line? Then you probably would not have it be 3. And so you only want to do this if it comes out to 3. So this is kind of like just another level of error checking. So I don't read if there's nothing there. If there is something there, I'll try to read. And then if the data looks like it's probably good, like 3 values, then we get down to business, okay? So x is going to be equal to the float, okay, because it came in as a string of values of element 0, right? Okay, y is equal to the float of values of 1, okay, and z is equal to float of values of 2, like that. Okay, Look at that. Now, remember how what we're going to do is remember how we created those arrays? Well, who was our array? It was X. Let me say one other thing. Okay, how come I had to declare these as global variables, but I didn't have to declare, those aren't there. Never mind. Never mind. Okay, I'll explain that when the appropriate thing comes up. But X raw is a global variable, and that's going to be equal to np numpy dot append. And what am I going to append to X raw? I'm going to append to X raw to X raw, which position? X. Okay. I'm going to append X to it. All right. And then where is it going to go? Minus max points, like that. Okay. Now, what this is going to be doing is it's going to be taking the X raw array, and it is going to be appending the latest X to it at up to the last point, okay, the minus X point. So this is like splitting the array. So basically this looks very awkward, but what it's doing is it's just appending the new value of X to X raw all the way up to maximum points. And then when it gets to maximum points, then it'll kick out the old one and it'll add the new one. And I could probably explain it better than that, but I'm not trying to teach arrays here today. So then this is going to be a new Y raw array, is going to be the old Y raw array with Y up until minus X points. And then this is going to be Z raw, and this is going to be Z raw, and this is going to be Z. Okay. Now I have my array. Now initially it'll just be a few numbers. It'll fill all the way up to 2000, but then X raw, Y raw, and Z raw will never get more than 2000. Okay. Now what I have to do is I got to tie this data to my scatter plots. What were my scatter plots? XZ scatter dot set data. Okay, it's going to be X is equal to X raw, Y is going to be equal to Y raw, and then X. That's not right. This should be XY. Should be X and Y. So X, Y, scatter, it's going to need the X raw data and it's going to need the Y raw data. All right. Now, we need to give it a brush. What does it look like? Well, I'm going to say my brush is equal to PG. Make the brush, and then I want to give it the color 0, 0, 255, and that should be blue, I do believe, if I'm thinking about this right. And then I think this is like a size that we're going to give it 120, like that. Okay, like how big do you want that to be? All right. You think that would show that graph? Let's see. I think I need to close this one more time, right? I think I got to close that one more time. Not make brusque, make brush. All right, let's see. Tension builds, and we're not getting any data. Why are we not getting any data? Why are we not getting anything show there? Okay, I'm going to go ahead and let me go ahead and kind of finish this code up, and then I'll try to see why it didn't work. I've got xraw np.append xraw x minus x points. I've got yraw np attend yraw y 0. Then I got xy scatter, set data, x is equal to xraw, y is equal to yraw, brush is pg, make brush 0, 0, 255, close that twice. Man, I am just not sure why that isn't working. Let's go ahead and put the other two in. You see the data was coming in, so we know that it's updating. And so this is xy, this is yz, and then here we will need y and yraw, and then this one we're going to make green, so this will be 255, and this will be 0, and then this is going to be xz scatter dot set data, and this is xraw, and then z. No. Okay, x and y. This is still x and y, right? This is still x and y. This is still x and y. It's just the x is this time going to be y raw, and this is going to be z raw, and then x and y is going to be x raw and z raw. Man, I am just not sure why that data, why nothing is showing up there. Let me look up here, see. And I found it. Okay, so I created the scatter plots here, right? I created the scatter plots here, but what did I not do? I need to take x, y plot, and I need to add that item that I just created, which was xy scatter, okay? And then I need the yz plot, and I need to add item the yz scatter. So I created the plots, but I didn't add the data to it, okay? So then xz plot dot add item is going to be what? xz scatter, like that. Okay? Moment of truth, moment of truth. So we're going to come over here, we're going to let you see this as well, and then we're going to run this thing, okay? Tension builds. Boom! Look at that. Look at that. I don't like the colors, though. I don't like the colors. I messed up the colors. I got blue, green, but I didn't get red. I got blue, green. I didn't get red. So let's see. Yeah, you see, I didn't, and you can't see that, can you? Okay. So on these colors, I went blue, green, but I need to go red. So that's got to go 0, and this has got to go 255. Like that. And then let's see. All right. Look at this. Now let's come back over here and see if we can see everything. I can't quite see everything. Okay. And you're going to need to see everything. I got to make that a little bit smaller. You guys got to give me just a second here for our okay, yeah. Give me just a second, because you really need to see this data, don't you? Okay, boom. So I've got live data coming in. Okay, now what I'm going to do is I'm going to rotate this in the XY plane. Now you guys tell me what's going to happen on the data as I rotate this in the XY plane. Somebody tell me, okay? Leave a comment. Tell me what's going to happen. It is going to make, all eyes on the XY plane, it is going to make a beautiful, beautiful, bodacious, wonderful, what? Circle, okay? And you see the program died, but I just hit the reset because all these wires, if you bump into them, you can kind of kill your I2C. Look at that. Now, this is what I'm meaning. This is what I'm meaning. Now, watch this. What I want is, okay, now why did this get a little bigger? Because I moved it further from the monitor, and you see as I come into the monitor, different things happen. So you see my calibration is going to be affected by being close to the monitor, but I'm going to go ahead and calibrate it here so that you can see. But just know in reality I need to get like 5 feet from the monitor to get a good calibration. But let's try this. Okay, so we're going to come in and we're going to run this thing again. Okay, so now I'm going to bring this up here, and if I was a little bit more adept and had things memorized better, I could probably put the position where this thing comes in, but we're not going to worry about that right now. Okay, so watch, I'm going to turn this, and as I turn it, I am mapping out my beautiful, beautiful circle, okay? I'm mapping out my beautiful, beautiful circle. Like that. And the more carefully you turn this, the more beautiful that your circle is going to be. Okay. Now, why is the XY plane not doing anything? Okay, because the magnetic field is coming like this. And I mean the XZ plane, the magnetic field is coming like this, and then in the X and Z, it is not going to see. Z is not going to change, right? So look down here. Z is not changing. Z is not changing. Why is Z not changing? Because that Z is this direction, and I'm not changing the magnitude of the field in that direction. Now you see I'm getting kind of a little bit of an oval, and I think the reason that I'm getting an oval is I'm not sitting perfectly flat. You see I've got this thing to kind of hold the thing on there, so it's not perfectly flat. Now, an interesting thing you saw here is now I am going to rotate in. I'm going to rotate in the XZ plane. I'm going to rotate in the XZ plane, and therefore the Z and the X are both going to be seeing that change in the magnetic vector. And now I turn it this way, and what do I get? I get a perfect circle that way. Okay, look at that. Now, who's being kind of ignored here? The person being ignored here is the YZ plane. Now here, what is changing? Z is changing, but Y is not seeing any change in the vector. So the YZ plane, nothing is changing, okay, for the Y. Okay, does that make sense? Okay, now who's been ignored? The YZ plane. Well, what I want to do is I want to come up here, and now Z is going to change, and Y is going to change. No, that didn't do it. Which direction is? It's like this. Now, you see how I've got it? Now, when I turn it like this, Y is changing and Z is changing. Okay, now do you see how much easier it is going to be to get our calibration values with this visualization? Okay, now let's think about something. Okay, we come here and let's run it again because I want to kind of get the data clear here. Okay. All right. So now I'm going to rotate it in the XY plane. So X is changing and Y is changing like that. Okay. So do you see what a nice pretty circle I got? And if I can try to go a little bit more carefully, you see there's some flat edges on there, and I can kind of try to do that a little bit more carefully. Okay, and then we're getting that absolutely beautifully. Now, you might come in and think that this would be your X max, X min, Y max, and Y min. But the whole purpose of this visualization, is to try and visualize it to get the real max. Okay, so here, right now, as I'm tweaking here, you see I'm kind of moving right here and I'm trying to get a max value. And flat, this is about as good as I can go. But now look at this. What if I bring this up like this? What? The circle just got bigger. Why did the circle get bigger? Because remember, the magnetic vector is not horizontal. So if I want to line up perfectly with the magnetic vector, the Earth's magnetic vector is not horizontal. Wow, something strange happened there. Let's start this thing again. I got it confused. Okay, so the Earth's magnetic vector is not horizontal, right? We looked last week where I am, it's coming in at 20 degrees, or it's coming in like 20 degrees like this. And so you see my magnetometer, my X magnetometer vector is not lined up with the Earth's magnetic vector, which is coming in at 20 degrees. So if I want that to be a maximum, I don't want to, let's just make the horizontal one just to show. Okay, so we're making our horizontal. Very good, our horizontal circle. Okay. Not absolutely perfect, not absolutely perfect. That's rounding it off a little bit better, isn't it? Just trying to get a pretty good circle here. Okay, pretty good circle. There. Okay, now that is not maximum because I'm pointing this way, but the magnetic vector, I keep hitting that and it's like confusing those things terribly. So we can make this code better later, and we need to get our wires more secure, but I just got to make sure not to touch those wires because then I get a lot of noise. Oh, you know what it is? This has a magnet in it. That would explain it. Okay, so that is not a really great pointer. So let's see if I can find a better pointer here. Okay, that kind of scared me. All right, so we're going to turn it and we're going to try to create a pretty good circle. Pretty good circle. What do you think? Pretty good circle? Okay, so now here we are. All right, so let's come back. This is the normal position here, pointing north. All right, now our X vector is pointing here, but the Earth's magnetic field, yeah, it's coming from north, but it's coming at 20 degrees. And so if I bring this to 20 degrees, now I'm seeing the maximum magnetic vector. Now what I want to do is I want to rotate it, and what you got to see is I've got to think of it like this, and then I've got to keep that axis and then I've got to spin around that axis. So I'm going to come up to that 20-degree axis, and then I'm going to spin about that axis. Okay, so now the 20 degrees is like here. Okay, and then there's that 20 degrees. Okay, I'm going to go, because I don't want to go all the way around. Okay, and so now we're coming up top, and then we're coming down. Okay, so you see how I got a much bigger circle? Why? Because I pointed exactly at the magnetic field, which here has an inclination of 20 degrees. Now, if you're in Dallas, you might have an inclination of 60 degrees, and you might have to bring it up like this, and you might have to rotate around that to get the maximum. Okay, so you've got to tilt it by your inclination, and then you have to rotate it around that tilt to get the maximum value. So you see, now in the XY plane, I really believe I have my X max, Y max, X max, X min, Y max, Y min. Okay, but now who have we been ignoring? The XZ plane and the YZ plane. Okay, so what can I do? I can now come up here, and now instead of having it straight up and down again, I want to what? I want to point it up a little bit by about 20 degrees, and then I want to rotate around that. Okay, and let's see, I need to get out of your way. I need to move this over here. Okay, so now do you see that? Now, even right here, as I'm right here at the top, I can try different inclinations to get absolutely the maximum value, and same thing here. Try some different inclinations. Do you see my points are starting to chew themselves up because we don't want to get over 2000? Okay, now what is the last one that we need to do? The last one we need to do is Z, the XZ. And so this is X, all right, and this is Z, and we want to rotate in what? X and Z. So now we're going to rotate like this, and let's give it that inclination. Maybe if I do it like this, you can see it better, okay? So now here we are, and instead of putting it straight up and down, let's see if I can show that a little better. Instead of doing it straight up and down, I want to incline it a little bit for the inclination. And yeah, you see we got a little bigger. And then I want to rotate around that. You know, that was really causing me a panic when we were just getting those radically different numbers. And I was thinking, how on earth could me touching that wire be causing those huge shifts in the data? Well, it's because I had a huge magnetic field in my pointer. Okay, so now you can see that what could we do here? We could alter this program. Okay, we could alter this program to be capturing the maximum and minimum values, but then we make sure we get the maximum and minimum values by watching the graphics as we're tweaking this to make sure that we're getting at these kind of corner points, the up, the down, the left, the right, making sure that we're getting those maximum values at those points. And then what we could do is we could then from there, we could calculate our three offsets and our three scale values. Then what we would do is we would take those numbers and we would put them back into our Arduino program. Okay, so let's see. I think this was not too tedious. I think this went pretty well. But let's see, again, I don't want to be sitting and trying to watch the numbers go by. So let's see if we can have it snag, and we want it to snag. We want it to snag what? The maximum, the minimum in X, Y, and Z, and then we want it to calculate the offsets. Okay, we want it to calculate the offsets. Now, what I want to do is, let's just see if we can create our offsets, our calibration offsets in XYZ and our calibration scales in XYZ, and then just have this program do it. And then to do the calibration, you could just go put them in your Arduino program. Okay. All right, guys, I was really worried about this lesson, but I think this one didn't go too badly. I know that I just really made some of you guys weary with the last time we did PyQt, and I'm truly trying to make it not that bad this time. Okay, guys, I hope you're having as much fun. And so what is your homework assignment? Your homework assignment is to take this program and go in and have it actually calculate your offsets and your scales, okay? And so this will give you the calibration parameters to go put in your Arduino program. I hope you're having as much fun with this class as I am. It's at this point that I give a great big shout out and a thank you to you Patreons, because the only way I am able to continue to produce quality, in-depth content every single week is with the support of my Patreon. So thank you guys. You can help this video by giving it a thumbs up and leaving a comment down below. When you do, make sure you ring that bell so you'll get notification when future lessons drop. And as always, share this video with other people, because the world needs more people thinking like an engineer and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.